The universe is unimaginably vast, stretching across billions of light years and containing more stars than we can count. Yet, despite this enormous cosmic stage, one question has haunted scientists and philosophers alike. Why haven't we encountered intelligent extraterrestrial life? With billions of potentially habitable planets scattered across the galaxy, logic suggests that civilizations should exist, and perhaps even thrive, beyond our solar system. And yet, the sky remains silent. This paradox has inspired dozens of mind-bending hypotheses and cosmic thought experiments, from the Fermi paradox and the Great Filter to the dark forest hypothesis, simulation theory, and even ideas about civilizations choosing to hibernate until the universe cools. Each explanation offers a different lens on life, intelligence, and the ultimate fate of civilizations, challenging everything we think we know about our place in the cosmos. Today, we're going to explore these cosmic paradoxes and hypotheses, revealing the strange, fascinating, and sometimes chilling possibilities about why the universe remains so mysteriously quiet. Comment which of them is familiar for you. 1. The Fermi paradox. The Fermi paradox asks a simple but puzzling question. If intelligent life is likely to exist elsewhere in the universe, why haven't we seen any evidence of it? With billions of stars and potentially habitable planets in our galaxy alone, logic suggests that civilizations should have arisen and spread, yet the cosmos remains silent. Scientists have proposed many possible explanations, from civilizations self-destructing before reaching interstellar communication, to advanced societies deliberately hiding, to the idea that intelligent life is far rarer than we imagine. The paradox highlights the tension between probability and observation, forcing us to confront both the limits of our knowledge and the mystery of our place in the universe. 2. The Great Filter hypothesis suggests that somewhere along the path from simple life to advanced, spacefaring civilizations, there exists an extremely improbable or dangerous step that prevents most life from reaching interstellar capability. This filter could lie in our past, meaning humanity has already overcome the hardest hurdles, or in our future, implying a potentially existential challenge still ahead. Examples might include the leap from single-celled to complex organisms, the development of intelligence, or the ability to survive technological self-destruction. The hypothesis provides one possible solution to the Fermi paradox, explaining why the galaxy seems eerily silent despite the high probability of life elsewhere. 3. Dark forest hypothesis. The dark forest hypothesis suggests that the universe is like a dark forest where every civilization is a hidden hunter. Revealing your presence could be deadly, because other civilizations might perceive you as a threat and destroy you preemptively. This explains the cosmic silence. Advanced societies may intentionally remain quiet, avoiding any signals that could attract attention. It's a chilling perspective on the Fermi paradox, portraying space as a dangerous place where survival often means staying invisible. 4. Zoo hypothesis. The zoo hypothesis proposes that advanced extraterrestrial civilizations know about us but deliberately avoid contact, much like zookeepers observing animals without interference. They might want to let humanity evolve naturally, without outside influence or disruption. This idea offers a peaceful explanation for the Fermi paradox, suggesting that the silence of the cosmos is intentional rather than evidence of absence. 5. Berserker hypothesis. The Berserker hypothesis suggests that self-replicating machines or probes could exist in the galaxy, programmed to eliminate emerging technological civilizations. These machines would explain the absence of detectable extraterrestrial life, as any civilization reaching a certain level of technology might be destroyed before it can communicate or expand. It's a dark but fascinating solution to the Fermi paradox, portraying the cosmos as a dangerous place for developing civilizations. 6. Estivation hypothesis. The estivation hypothesis proposes that advanced civilizations may enter a state of dormancy, hibernating, until the universe cools and energy becomes far more efficient for computation. In this scenario, civilizations are physically present but intentionally inactive, waiting for optimal conditions to maximize their longevity and productivity. This could explain why we see no signs of intelligent life. They are simply biding their time in a cosmic slumber. 7. Simulation hypothesis. The simulation hypothesis suggests that our reality might be a computer-generated simulation created by a higher intelligence. If true, many cosmic mysteries, including the absence of detectable extraterrestrial life, could be deliberate constraints or design choices within the simulation. This idea reframes the Fermi paradox. Perhaps aliens exist, but we cannot perceive them because the simulation hides or limits such interactions. 8. Planetarium hypothesis. The planetarium hypothesis proposes that the universe we observe is an artificial construct, like a cosmic stage, created to hide the true nature of reality or other civilizations. In this scenario, the apparent emptiness of space and the silence of intelligent life may be intentionally designed. This offers a radical explanation for the Fermi paradox, suggesting that what we see is a controlled illusion rather than the full cosmos. 9. Firstborn hypothesis. The firstborn hypothesis suggests that humanity may be among the earliest intelligent civilizations in the galaxy. If true, there simply haven't been older civilizations for us to detect yet. This perspective offers a simple solution to the Fermi paradox. The universe isn't empty of life. It's just that advanced life is only just beginning. 10. Rare Earth hypothesis. The rare Earth hypothesis proposes that while simple microbial life might be common in the universe, the precise conditions required for complex, intelligent life are extremely rare. Factors like a stable orbit, a protective magnetic field, the presence of a large moon, plate tectonics, and a hospitable star all need to align perfectly. This could explain why, despite billions of stars and planets, advanced civilizations remain elusive and the cosmos appears silent. 11. Cognitive horizon hypothesis. The cognitive horizon hypothesis suggests that alien intelligence may exist, but their minds, communication methods, or technologies are so different from ours that we simply cannot recognize them. Their language or signals might lie beyond our sensory or technological capabilities. In this case, the universe isn't silent, we just lack the cognitive tools to detect or understand other civilizations. 12. Transcension hypothesis. The transcension hypothesis proposes that advanced civilizations evolve inward, focusing on miniaturized, high-efficiency computing or virtual realities rather than expanding into space. As a result, they become practically invisible to astronomical searches. This could explain the silence of the cosmos. Intelligent life exists but has retreated from the observable universe to pursue internal development. 13. Post-biological hypothesis. The post-biological hypothesis suggests that advanced civilizations may transition from biological life to machine or AI-based forms. Such entities could have drastically different needs, behaviors, and methods of communication, making them nearly undetectable with our current technology. This hypothesis offers another explanation for the Fermi paradox. Intelligent life exists, but it no longer resembles the biological life we expect to find. 14. Percolation theory in civilization spread. Percolation theory in the context of civilizations suggests that galactic colonization might be uneven and patchy. Even if multiple civilizations arise, they may fail to connect or expand uniformly across the galaxy, leaving vast regions, including our own, untouched. This could explain why we see no evidence of alien empires. Space may be populated, but the spread of civilizations is incomplete and fragmented. 15. Galactic Club hypothesis. The Galactic Club hypothesis proposes that advanced civilizations form a kind of interstellar club, with rules, such as avoiding contact with less developed worlds. Humanity might simply not be a member yet, which would explain why we haven't been contacted. This idea frames the silence of the cosmos not as absence, but as intentional discretion by older, more advanced societies. 16. Self-destruction hypothesis. The self-destruction hypothesis suggests that most technological civilizations eventually destroy themselves through war, environmental collapse, or runaway artificial intelligence. If true, their lifespan as detectable civilizations would be very short, making it unlikely for us to observe them. This idea offers a grim solution to the Fermi paradox. Intelligent life may be common, but it rarely survives long enough to communicate across the stars. 17. Temporal prime directive paradox. The temporal prime directive paradox suggests that advanced civilizations, or even time-traveling entities, may deliberately avoid interfering with less developed worlds like ours. By following a kind of cosmic non-interference rule, they ensure natural evolution and technological progress continue undisturbed. This could explain the Fermi paradox. Intelligent life may exist nearby, but ethical or strategic choices prevent contact. 18. Silurian hypothesis. The Silurian hypothesis proposes that advanced civilizations might have existed on Earth long before humans, but left little to no trace due to geological processes like erosion and plate tectonics. If true, technological life could have arisen and vanished entirely, leaving us unaware of its existence. This paradox challenges our assumption that humans are the planet's first civilization capable of advanced technology. 19. Panspermia paradox. The panspermia paradox suggests that life could easily spread across the universe via meteorites, comets, or interstellar dust, seeding multiple planets with similar organisms. If this is true, we might expect life, and perhaps intelligent civilizations, to be widespread. Yet, despite this potential distribution, we see no clear evidence of extraterrestrial life, raising the question: why is the cosmos so silent? 20. Anthropic silence hypothesis. The anthropic silence hypothesis proposes that we exist in a rare, quiet era of the universe where intelligent civilizations are either isolated, extinct, or deliberately silent. Our observations are limited by the timing and location of our own existence, meaning the galaxy may be teeming with life. We just happen to live in a cosmic, silent window. This offers one possible explanation for the Fermi paradox without assuming the absence of extraterrestrial civilizations. 21. Hart-Tipler conjecture. The Hart-Tipler conjecture suggests that if self-replicating probes, von Neumann probes, are feasible, advanced civilizations should have already explored and colonized the galaxy. Their absence implies either intelligent life is extremely rare or technological civilizations rarely survive long enough to launch such probes. This idea adds another layer to the Fermi paradox, highlighting the surprising silence of the cosmos despite the theoretical ease of galactic exploration. 22. Waterworld hypothesis. The waterworld hypothesis proposes that many potentially habitable planets are dominated by oceans with little or no land. While life may exist on these planets, the lack of landmasses could make the evolution of tool-using, technologically advanced species extremely unlikely. This could help explain why we see few, if any, detectable civilizations despite the abundance of habitable worlds. 23. Gaian bottleneck hypothesis. The Gaian bottleneck hypothesis suggests that while microbial life may arise on many planets, maintaining long-term planetary stability needed for complex life is extremely rare. Environmental changes, catastrophic events, or planetary instability often prevent life from evolving into advanced civilizations. This could explain the Fermi paradox. Simple life might be common, but intelligent life capable of interstellar communication is exceptionally scarce. 24. Technological adolescence hypothesis. The technological adolescence hypothesis proposes that civilizations reach a fragile stage where their own technologies, such as nuclear weapons, artificial intelligence, or ecological exploitation, pose existential risks. Many societies may fail to survive this critical period, preventing them from developing interstellar capabilities. This offers a possible explanation for the Fermi paradox. Advanced civilizations may exist briefly but often destroy themselves before becoming detectable. 25. Cosmic quarantine hypothesis. The cosmic quarantine hypothesis suggests that advanced civilizations may intentionally isolate or avoid contacting emerging civilizations like ours. This quarantine could be for ethical reasons, to prevent cultural contamination, or to protect us from potential harm. According to this idea, the silence of the cosmos isn't due to absence, but deliberate restraint by more advanced intelligences. The universe is full of mysteries, and these paradoxes and hypotheses show just how little we truly understand about life beyond Earth. From the silence of the stars to the possibility of civilizations hiding, hibernating, or evolving in ways we cannot perceive, each idea challenges our assumptions and sparks wonder. What do you think? Are we truly alone, or are we simply looking in the wrong way? Share your thoughts in the comments, subscribe for more cosmic mysteries, and join us as we continue exploring the deepest questions about the universe and our place within it.